Hello everyone, welcome to the channel. Today's topic is Foundation Models in Artificial Intelligence. In this video, we'll quickly look into what are foundation models. Foundation models or foundational models both are same in artificial intelligence. Let's begin. Foundation models are general purpose models in artificial intelligence. Foundation models are trained on vast amount of data and they are trained on diverse dataset. The training dataset consists of text, image, videos in different languages and dialects. Therefore, foundational models have broad range of general skills, general knowledge and reasoning capabilities. Foundation models, short form is FM. How these foundation models are trained? FMs are trained on large unlabeled dataset. They are trained using self-supervised tasks such as learning to predict next word in a sequence of words. If you want to create a new model or train a model for a specific task using FM, then you need very little supervised data. What are the capabilities of foundational models? FMs are capable of broad content generation for chatbots, general Q&A, summarizing documents across different domains. You can think of foundational model as a vast open area of space. In that space or land, we can construct office building or use that space for residential purpose, or that space can be used for multi-purpose like parking zone, play zone, entertainment zone. So foundational models are like open space, and using these FMs we can create specialized models like LLMs, SLMs, multimodal models, tiny models for applications which need domain expertise. For example, domain expertise in education sector is different from domain expertise in medical sector. To train an AI model in medical sector, we need data related to medicine, healthcare. To train an AI model for agriculture sector, we need data related to plants, crops. Foundational models trained on general data of various fields. But foundational models do not have any specific domain expertise. Moving on to the next slide. We'll look into foundational models and other specialized and core AI models, LLMs, SLMs, tiny models, vision models, diffusion models. Foundation models, FMs, are general purpose models trained on massive amount of data. We already saw these models in the previous slide. Then comes large language models, LLMs. They process vast amount of text data. They are used in translation applications to translate text from one language to another, say translating a poem in English to Spanish. They are also used in voice assistant applications. Then comes small language models, SLMs. These are trained to meet specific requirements for on-device solutions, for on-device AI. Then comes the tiny models. These are generally used in devices with small form factor like smartwatch, smart glasses, or IoT devices, IoT sensors. Then multimodal models. They process different data types like text plus images. They are trained to understand multiple formats simultaneously. Multimodal models can read signboards having both text and images. Multimodal models, large language models, are used in generative AI to generate videos or images by voice or text prompts as inputs. Foundational models also process different data types, text, image, video, etc. Then how those multimodal models are different from foundational models? There is a difference between FM and multimodal models. Both FM and multimodal models are trained on different types of data types, but multimodal models are fine-tuned with specific data set to specialize in a particular domain like finance domain, agriculture domain. Multimodal models take general knowledge of foundational models and fine-tune with specific data set to achieve high accuracy outputs. Like OpenAI, GPT-4 and above version process text plus image as input. There are also vision models deployed in computer vision. Then comes the diffusion models. Diffusion models are models that start with random noise and gradually refine by denoising process until the model produces high realistic images so that the generated images look natural. Example, ImageGen, Stable Diffusion are popular diffusion models. Foundation models are thinking part of AI agents. As foundation models operate in variety of domains, text, audio, video, image, AI agents can handle multimodal inputs. These specialized core LLMs, multimodals, diffusion models help to build generative AI models, AI agents, and much broader AI models and applications. Moving on to the next slide. We will look into the purpose and limitation of FM and core models. Starting with data size. FM models are trained on trillion parameters, terabytes of data. Other models like LLMs, multimodals, SLMs, tiny models are trained on billions or millions of parameters and on gigabytes of data. High training cost as FM model process large amount of data. Other models training cost is less compared to FM. FM model memory requirement is high. Other models memory requirement varies from high to low based on training dataset and parameters. FM models need more computational resources like advanced hardware and software capabilities. Other models use graphic processing units or TPUs, tensor processing units. Purpose of foundational models. FMs are mainly developed for research work. They have general skills, general knowledge about various domains, but not expert at any specific domain. Due to vast amount of data and high training cost, these models are not directly used in production. But the latest versions of these foundational models are optimized to use in specific domains. Specialized models are built for FM models and used in production, medical, legal, finance, agriculture, voice assistance, and many more applications. Other models like LLMs, multi-models developed from foundational models are suitable for production. They are deployed in medical fields to diagnose diseases like cancer at early stages, in agriculture field to monitor the plant growth, crop yield, in finance sector and education sector. FMs cannot fit on device with small form factor like mobile phones due to high memory footprint and high processing power, and they require more computational resources like high RAM GPUs. So for on-device AI applications in resource-constrained environment, small language models or tiny models are used. SLMs or tiny models are used on devices with small form factor, mobile devices, wearable devices, smartwatch, smart glasses, IoT sensors. Other models, small or large models, can be built from FM models by considering FM as base model. FM can break down the task logically. Moving on to the next slide. Now let us have a quick recap. Before discussing these questions, if this video is informative, then please like and subscribe to the channel. First question. Foundational models are trained on unlabeled data and self-supervised tasks. Is this statement true or false? Foundational models learn and are trained on unlabeled data, and FM learns from self-supervised tasks, so the statement is true. Next question. Which of these is true about foundation models? Language models, denoise, general skills, tiny models. Foundational models are trained on massive data, so they have general skills, general knowledge. Diffusion model denoises and produce realistic images. Answer is C, general skills. So this brings us to the end of this video. If you have any questions, please let me know. Please like, share and subscribe to the channel. See you in the next video. Until then, thank you for watching and happy learning.